force. It is purely because of this friction only that is I am able to hold this pen in my hands. It is because of friction only when we apply the brakes the car stops. It is because of friction only that is in the machinery we have wear and tear and we have losses. We have to change the tires of our car regularly because of this wear and tear. So we see that as friction is at times it is useful also, and at times we don't want friction at certain places. If we wish to understand friction, that is its origin, it is maybe we may have to see the things not only that is from our bare eye, but what is happening at the microscopic level. Friction arises. Friction is a force that arises because of irregularities between the surfaces. Over here we are primarily interested in the dry friction, that is friction between the different surfaces of the bodies. We also have a liquid friction where we talk about what is the friction when the liquid is flowing, then what is the friction between the different layers of the liquid. Right now our aim is to understand dry friction, or what you say just friction. So friction is a force which arises because of the roughness of the surfaces, because of irregularities of surfaces, because the surfaces they are not smooth, they are irregularities and they are hills and valleys, they are like this, and this roughness of the surface is not visible to the bare eye. Though let's say if we touch it by hand, we may have a feeling that this is rough, this surface is smooth or rough, but there is always a difference in the degree of roughness. So when we talk about the irregularities, we may be seeing that this is a surface and over here there is a block. But if we see at the microscopic level, we will find that this is actually the surface is like, if we magnify that is what is happening, all the surfaces they are like this. At the microscopic level we see that is if this is one surface, that this surface, and my upper hand, this hand represent this surface and this hand represent this surface, so it means they are interlocking. They are hills and valleys, ups and downs, they are ups and downs, they are hills and valleys, and they got stuck like this. So when we try to move it, then it is difficult. So initially it doesn't move, but when we apply a greater force, then it may start moving. So it may start moving like this. It may not be hopping, it may be hopping, but it may not be visible to our naked eye because the amplitude is very small. So what we see is, as we are not able to see these hills and valleys because they are so small, but they are playing a definite role in the motion of the objects, between the relative motion between the surfaces. Also, when these irregularities and these irregularities, they are interlocked and we try to move it this way, then certainly that is some of the irregularities, they get broken. That is what we call a wear and tear is happening. To reduce this friction at unwanted places, we can polish the surfaces, we can put the lubricants, we can make it more smoother, but all these things, they can only reduce the friction, they cannot make it equal to zero. The friction can only be reduced by certain means. Initially, when we smoothen these two surfaces, then the friction, it reduces. But after some time, it drastically increases. When we excessively smoothen the surfaces, then what happens is, molecules at this level and molecules at this level, they are in touch with each other, they are in contact with each other, and what comes is, that is a cold weld is formed. It is like a weld only, it is difficult to break it. That is, cold weld is formed, and then moving one surface or the other surface, it becomes more difficult. Now we are not saying that the surfaces, they are frictionless. Now we have introduced the concept of friction, and our aim is to understand this frictional force, that is how and what is the value and how it works and in which direction the friction force is there. Because when we say friction and it is a force, obviously the force is a vector quantity. It has to have a magnitude, it has to have a direction also. So we shall be talking about both the things, that is how to find the magnitude and how to find the direction also. And there is a roughness between these surfaces. So when we try to move some body, suppose there is a heavy box or so, when we initially try to move it, it doesn't move. But once it moves, then it is very easy to keep pushing and keep it moving. Then we require lesser force. But initially we require a bigger force, and then to maintain in motion, we require a smaller force. That is, when this block is stationary with respect to this surface, then the maximum value of friction, that is static friction, that is limiting value of static friction. But once it starts sliding, then we require lesser force to maintain that motion. Reason being, initially we have full interlockings like this. Between this surface and this surface we have full interlockings. But once it starts moving, it goes like this, it goes like this. It keeps on hopping, there is not a full interlocking. So as a result, to maintain that motion, it is much easier compared to when we intend to put this block into motion. It is only because of friction that is we are able to walk on a surface. Had there been no friction, then this motion, it would have been utterly difficult. When we walk, then what we do is, with our feet, we push the earth in the backward direction. That is, we push the earth. Now, we push the earth in the backward direction. That is, we do action or reaction, that is, we apply one force, and to this force, earth applies a force in this direction. Now, suppose these are irregularities on the surface of earth, and these are irregularities which are there in our shoes or in our feet. So, as a result, when we push it backward, that is, we get a force in this direction. If we wish to increase the friction, that is these irregularities, how these interlocking, then we can have even a shoes with the spikes also. They are more of, let's say they get stuck, so that when they apply a force, these interlockings, they are not easily broken. Whereas, had we been on ice, then over there in ice, there may be slightly interlockings only, small interlockings only. That is, as soon as try to move it, then these small interlockings, weak interlockings, they get broken and we can fall down. So on the slippery surfaces, these meshing of the interlockings is not that huge as compared to on a rough surface. With the spikes in their shoes, sports persons, they have a better interlockings between the lower surface of their shoes and the ground. As a result, they can push the earth backward harder. As a result, that is, it means they can apply a bigger force onto the earth in the backward direction, and they can have a better acceleration in the forward direction, because now they are also having a bigger force in the forward direction. The same applies, that is, if they have to retard it, they have to apply the brakes, they have to come to a stop. Then because the grip is better, so they can have a better force and they can have a better retarding force also, and they can have a bigger retardation. So origin of friction is the roughness between the two surfaces. Origin of friction is the irregularities between the two surfaces. Origin of friction is, that is, how these irregularities, hills and valleys, they are messed up. If they are more deep, then obviously the friction is more. If they are shallow and these irregularities, they are weak, their strength is weak, that is easy to break, then obviously then the friction will be less, as the case of ice.